Hey folks, Darren with Fervent Astronomy. Today, I've got a diminutive little lens, the Sigma 17mm f4 DGDN. This is part of their I series of lenses, or contemporary series, but the I ones. And these lenses are all, I would say, experience lenses. They're more often than not slower in aperture. This one, f4, is fairly slow, as you can imagine. But they've got manual aperture rings, nice focus rings, everything's metal. They've got usually a metal hood and this cool magnetic lens cap. But why do I have this pretty slow lens? Well, I actually bought it to go with this Nikon ZF. Why? How? Well, you can actually adapt these lenses to Nikon cameras using some adapters. There's two different brands out there, TechArt, I think, and the one I use is the Megadapt ETZ21. As of the time of recording, there's a pro version of that adapter out as well with minor changes. It lets me use this really vintagey aesthetic looking lens on this really vintagey aesthetic looking camera. And unlike Nikon's special edition lenses, which are basically just plastic, it's all metal. As I mentioned, we've got, oh, this is just so good. Manual aperture ring with that A setting where you can then control aperture from the camera. A quick look over the lens reveals no declickable aperture switch and no aperture lock switch. So you can't lock this lens in either the A or the manual ranges there. You just have to try and not hit it. That being said, this lens is, I feel like, designed around the experience, the manual experience. So I use the manual aperture ring because I'm the best hipster, the best one, aging hipster, but the best one. We do have, of course, an AF to MF switch, which has actually a pretty satisfying click there, and this nice, well-dampened knurled metal manual focus ring. It's great. The hood itself here is metal and it is a pedal type. And then got the teeny tiniest little front element here, which is just great. This lens is super compact on the camera, super wide. And at f4, you might expect, even though it's a little bit slow, it's gonna hopefully not have too many aberrations wide open. F4 is perfectly reasonable for doing a tracked image. 17mm is not traditionally a tracked type of focal length, but if the results are worth it, I'm willing to do it. So let's take a look in Lightroom and we will see how this little lens performs. Howdy folks, welcome to Lightroom, where we're looking at the Sigma 17mm f4 DGDN contemporary quote-unquote I-series lens for, in this case, Sony E-mount, but also L-mount and possibly other mounts down the line. Being a Sony mount lens, you can adapt this to Nikon Z-mount, which is something that I am a fan of doing. That being said, let's take a look at this lens, which is almost assuredly a terrible choice for astrophotography. But hey, what are we doing here? Who cares? Let's take a look. So let's talk about methods here. We've got a few samples. I think I've got some doubles here actually, but a few of them are taken with the Sony A7R Mark V 60 megapixel camera. These are tracked shots, 60-second exposures. So we got 1, 2, 3, 4, 4 through 5.6. That's not very practical. And then we're coming down to these two samples here, which I think are just the same. And this is f4, 15-second exposure taken with the Sony Alpha 1 50 megapixel camera. And these are definitely going to suck. And I didn't bother taking any at any lower apertures or any tighter apertures because it would just be black. So essentially, we're going to have a whole review here that's focused on why you need fast lenses, I suppose. The track samples are tracked with the Fornax Mounts LighTrack II portable star tracker. Fervent Astronomy happens to be Fornax's North American distributor. So if you are at all interested in that, go to the tracker, head over to ferventastronomy.com. You can learn more. I don't know why I did this. Let's do it. All of these images are captured at the respective camera's second base ISO. These are ISO invariant cameras, which is to say that they only have, I think in the case of both of them, 2 real ISO values, 2 analog amplification stages. From a practical standpoint, that means that if I take an image at ISO 320 with this camera, 7R Mark V, and I take a image at 12,800 with this camera, they are the same image. Just the one at the higher ISO is locked in at a higher exposure. What the camera does is it takes this base image, basically, at ISO 320, and it cranks the exposure up to equal 12,800 or whatever it is, and it locks it in there. Now, that's not the best thing to do, in my opinion, because, one, you don't gain anything. Sure, on the back of the camera, it might look like a brighter scene, but it's not actually giving you more information. You're actually losing some. So what's going to happen is you're going to lock your highlights in at a higher level, but you're going to get the same noise and the same ability to recover the shadows as if you shot here at ISO 320. So I can shoot at 320, I can raise the shadows, I can raise the exposure, I can match perfectly a shot taken at that 12,800. The noise is going to be the same, all that's going to be the same. The key difference is if there was something bright in the frame, like a couple big stars, galaxy core, maybe a bright star forming region in a nebula, I can maybe, if I shoot at the base ISO, retain some of those highlights that might otherwise be pure white in the image taken at a higher ISO. So that's why I do that. If you want to learn more about that, get a better explainer, there's a link in the description. It'll bring you back to ferventastronomy.com, where you will get a bunch of different links to that article, but also to some of these samples that you can download and pixel peep. These are not great works of art by any means at this point, but as always, please respect my copyright. Please respect the sweat equity that I put into getting these samples and making this review. So please don't redistribute them online or otherwise, misrepresent them as your own. Please don't make your own review using my samples. Just use them in good faith for the reason that I'm providing them, which is the assessment of this lens. I don't know why anyone would want to watch this video, but if you're here, I just want you to know that I appreciate you. That being said, I don't know the best way to start this. You know what? We gotta fix this first. Let's raise the exposure through the magic of editing. Editing! Hey, look at that. They still look almost all black. First things first, I'm gonna take a look at this one. See these little, I don't know, tadpole looking things? I knocked the tripod and it caused this, so that explains why we have 2 of these, getting rid of that. Now that that's out of the way, let's come in here, and this is the 15-second exposure with the Alpha 1, and yeah, not a lot going on here, folks. Very, very dark. I don't think that this is going to be the wide field lens of the century, although you might find that this is an okay lens for star trails. We zoom in here. This is, I guess the stars are fairly round, 17 mil, probably could have pushed the exposure for longer, but to be honest, it wouldn't make a huge difference. As we get out here, we're experiencing some stretching, and that's something we'll look at more in some of the other samples here. So this is not going to be your primary on tripod lens, and this is why typically I would say an f2.8 lens is the minimum standard for taking any nightscape type shots. But let's go over here, and this is a 60-second exposure at f4, and we see, oh, now we actually know where we are a little bit. I can see Ursa Major here, okay, a little bit brighter. So this is tracked, so we're going to get hopefully round stars, and we do. They are not trailing. Way to go, LighTrack II. Now, that being said, things are very noisy here. Obviously, this is still quite underexposed, even though it's 60-second exposure. But things that I'm not seeing a ton of chromatic aberration, maybe like a smidge of spherical aberration, but not really. These brighter stars are a little lower contrast, bloating a little bit, but definitely not anything to worry about. Vignetting, there is vignetting. If you look at the navigator, it's a little easier to see. And it's darkening the corners, but let's be honest, it was dark everywhere. With the underexposure, it's hard to tell if it's nice contrasty at f4. It's not, f1.2. It's likely not going to have any contrast problems wide open, so that's nothing to worry about. Let's look in the corners, or let's look at the edge first. Here's a bright star. Okay, so here we've got some little space armada of space planes flying in towards the center of the frame. This is astigmatism. This is not coma. Some of you might be going, oh, the coma is bad. This is not coma. This is astigmatism, and we'll talk about it here. So from the center of the frame to the edges, there's infinite radii, and anytime you have a bright pinpoint on the edges or corners, you might suffer these aberrations, which are astigmatism. So there's a stretching along that radii from the center to the edges, then that will, in this case, you can see that the little points all pointing to the center of the frame. That's tangential astigmatism. Tangential astigmatism is when the lens can't take a point of light and resolve it into a point, and it gets stretched along one of these radii. The wings of these little space planes are sagittal astigmatism. So along any one of these radii where there's a star, you might also have different astigmatism at a 90-degree angle, and that's what makes the little wings here, and it tends to look like it's ringing the frame. It's always kind of at a 90-degree angle, and that's what gives us these little shapes. Sometimes they look more like birds. The wings can be curvy. Sometimes things kind of spread out a little bit more here with the very bright stars, but what you're getting is that astigmatism. So what's coma? Well, I don't see any here, so I can't really show you. It actually very seldom can show coma, but coma is when the star will sort of fuzz out on one side and make a bit of a wedge shape, a bit of a delta shape, and all those fuzzy tails basically will either point towards the inside of the frame for internal coma or the outside of the frame for external coma, and they gain their name from comets. Coma, chromatic aberration being the official term. So it looks like little comet tails, so it's called coma. But I don't really see any here, so we won't really worry about that. There is that astigmatism though, and as far as something like field curvature is when one part of the frame, let's say the center of the frame is in focus, but maybe the edges and corners are out of focus. It's really hard to tell here, but I'm really suspecting there's not a lot of field curvature, because while we do have these little space planes from the astigmatism, they are pretty defined and pretty tight, and the stars that are the dimmer stars in between look pretty okay, pretty tight. Same here. I mean, it's an f4 lens. I'm not really surprised. So field curvature, I don't think is an issue. Everything looks to be in focus from center to corners. That being said, that doesn't mean that there's not any distortion or whatnot. So we'll look at that in a moment, but let's stop this lens down and see what happens. F4, 4.5, you can see that this brighter area is now disappearing at 4.5. It's fairly even. There's still a bit of vignetting, but it's more even. That being said, 4.5, not a great aperture for astrophotography. 5, 5.6, and we're just gonna look here. 5.6, it looks like the sagittal astigmatism is resolving. If you open it up a little bit, it starts to come back. That being said, I don't think that's a useful thing to do. If you're gonna shoot this lens at all, I would say shoot at f4 and just don't worry about this, basically. Let's jump into the develop module. We didn't really have chromatic aberration too bad. You can just click that on, it never does anything anyway. Here, this purple is technically chromatic aberration, so we can take the defringer and click in there. Market improvement, right? Anyway, jokes aside, zoom out here. Profile corrections, engage. All right, now even though there is a built-in lens profile, the corrections are coming up and they are doing something. And here, pleased to see actually, the vignetting is getting corrected, although if we zoom in, we see things are very, very noisy. And mind you, this is a 60-second exposure, wide open at f4. So that's happening, and this lens has obvious barrel distortion. The middle of the frame is kind of bulging out towards the viewer, the edges, corners, kind of pushed away from the viewer. And so when we enable those profile corrections, the center is getting flattened away from the viewer, and the edges and corners are getting pulled towards the viewer into the same plane, and it's correcting that geometry. If we kind of zoom out the scale here, you can see what's happening here. This is getting stretched out a little bit. So we are losing a little smidge of our field of view, not so much on the top and bottom edge. You can watch the stars and they don't really leave the frame. Definitely we're losing some diagonal field of view here. These stars are stretching out of the frame, and we're losing a bit on the left and right edges, but I mean, it's nothing to really worry about. 17mm lenses is quite wide. You're still retaining a good field of view. All that being said, I think this lens, I mean, again, this is a 60-second tracked exposure. I don't think this should be necessarily anyone's primary astrophotography lens, but this is what it performs like on the sky, and it might be something that you might want to use for star trails if you have it already and you don't want to buy a special lens just for doing that. It's fairly wide. It'd be a good candidate for that. So yeah, let's wrap this up. All right. Well, is this going to be my #1 wide angle lens for astrophotography for Aurora? No, of course not. This is an experience lens, and it really delivers a good experience when using it in its intended purpose, but in a pinch, tracked 17mm, I'm not against it. How about you? Did you find this lens interesting? Are you just watching this for fun because you like to hear me talk? Do you just like seeing toys for cameras? You know what? All of those are great. As long as I've got your eyeballs, I could care less. So thanks for watching this review. Hope you found it useful if you are going to get this lens, and we'll see you next time.